My article is about the COVID-19 vaccine, one of the biggest issues of the present era. Many people have already been vaccinated against COVID-19, and almost everyone in Korea has heard of it a lot. However, many people do not know exactly what side effects the COVID-19 has, what side effects vary depending on who it is, and what to be careful after being vaccinated. In particular, the side effects of the COVID-19 vaccine are the most frequently mentioned these days, but many people do not know exactly. Vaccine side effects that many people know include fatigue, muscle pain, headache, fever, chills, and nausea, but they are not the only ones. Typical side effects of the severe COVID-19 vaccine include anaphylaxis, thrombosis with thrombocytopenia, and the occurrence of Guillain-Barré syndrome, myocarditis, and pericarditis, and in the most severe cases, death. And many people know to some extent that each person has different side effects of the COVID-19 vaccine, but they probably don't know exactly. The side effects of the COVID-19 vaccine are more severe in women than in men because of the influence of a female hormone called estrogen, which plays a role in promoting immunity. In addition, the second inoculation tends to hurt more than the first inoculation of the COVID-19 vaccine because our body has learned to quickly recognize and attack the virus through the first inoculation.
What is a drug delivery system (DDS)? The drug delivery system is a method of efficiently delivering drugs to the target site, and various systems have recently emerged depending on the patient's disease or physical characteristics. Nanoparticles called needles, which are made by imitating viruses, are also attracting attention as a new drug delivery system. There is an outer skin and inner space like dumplings, so genetic therapies can be put in empty spaces. Putting a gene therapy into the needle particles and binding a protein carrier to the surface of the needle can deliver the gene therapy to the inside of the brain cells, which are the most accessible. However, in terms of effectiveness, it is still not at a satisfactory level, and in this situation, a novel and interesting drug delivery system has recently emerged for cancer cells, drawing attention. The core of drug delivery system technology for cancer treatment is to create a molecular-sized ultra-thin object smaller than the size of micrometer and deliver cancer-destroying drugs in it to cancer cells.
What nanomaterials are used in cosmetics? One of the most commonly used nanomaterials is titanium dioxide. Titanium dioxide is a mineral that exists in the natural environment. Titanium dioxide may be pulverized or synthesized, thereby generating particles in a micro size or producing particles with a smaller nanomaterial. Nanotitanium dioxide also exists in nature. Titanium dioxide have been used in sunscreen to reflect or scatter ultraviolet rays. In addition to protecting the skin from ultraviolet rays, nanoforms also provide advantage in prescribing products that make the skin transparent by reducing applicability and white cast. If so, is the nanomaterial used in cosmetics safe? In conclusion, many international expert organizations have completed evaluation of nanomaterials and have confirmed that nanomaterials are safe to use. For example, the European Union's Consumer Safety and Science Commission issued recommendations for nanomorphism of zinc oxide in 2012 and titanium dioxide in 2030. It was concluded that both substances were safe to use sunscreen under the recorded specific conditions.
What is a semiconductor, which is a hot issue these days? It is defined in the dictionary as belonging to the intermediate area between conductors and non-conductors. And precisely, it plays the role of calculation, control, information storage, signal conversion, communication act, where semiconductors enter into all products where electricity is used to perform these functions. This type of semiconductors are largely divided into memory and non-memory semiconductors, and memory is again divided into DRAM and NAND flash. DRAM is volatile because it is a type of RAM, but NAND is non-volatile. Therefore, NAND is used for storage device, and DRAM is used for the remaining memory computer components. Memory semiconductors are easier to make than non-memory, while non-memory semiconductors are difficult to design and difficult to produce. Therefore, sophisticated technology is required, and the amount of capital invested is much larger than memory.
The special theory of relativity is the theory that means the relationship between time and space based on the principle that the speed of light is the same for all observable in an inertial system. Background of special theory of relativity. In the 19th century, scientists believed that waves travel through a medium, so light, a type of wave, would also travel through a medium called ether, and Michelson and Morley experiment about it, which is called the Michelson and Morley experiment. This experiment will relieve existence of ether from the difference in the speed of transmitted light. As a result, ether did not exist. Assumptions of the special theory of relativity. Assumptions of the special theory of relativity are principle of relativity, principle of constants of light velocity. First, principle of relativity means that the laws of physics hold the same in an inertial coordinate system. Next, principle of constants of light velocity means that the speed of light traveling in a vacuum is constant regardless of the speed of an observer or light source when viewed in inertial coordinate systems. For example, when a person in a car traveling at speed v shines a laser light of speed c, the observer is measured as a c, because the speed of the laser light is v plus c. Phenomenon by the special theory of relativity. There are three types of phenomena according to the special theory of relativity. These are relativity of simultaneity, time lag, and length contractions. First, relativity of simultaneity means that two events occurring simultaneously in one inertial coordinate system may not occur simultaneously when viewed in the other inertial coordinate system. Next, time lag means that when a stationary observer sees a fast-moving observer, the opinion time is observed to be slow. Finally, length contraction means that an observer in an inertial coordinate system observes that the length of the object is contracted when he sees a relatively moving.